class we have discussed about the cavity based problems. We are discussing about the cavity based problems. Let me discuss. So what we are discussing means we learned one law there. What does that law it tells means? Mass remaining into R remaining is equal to M cut into R cut. Similar way, this is first law. If we add mass, no same thing we can do it. Mass remaining into R remaining into M add into X add or R add. We can write it. The same formula we can add for what? If we add the mass also here. Fine, let me solve few numericals on this here. So first numerical what we are taking is we are taking from H.C. Verma. In that numerical, what does it says means we are having one disk. We are having one disk whose radius is R by 2. From the disk, what they removed means they removed one part like this. They removed one part like this, whose square removed part diagonal is how much means A by 2. Now what we need to calculate? We need to calculate the locate. We need shift in center of mass. We need to locate here. Shift in center of mass. If you want to locate now here, how much removed mass we have to calculate? To calculate that side area, we need to calculate side length. So this part remains here. That removed mass we need to calculate. So how to calculate that means first we need to calculate side length. Diagonal value we got to know. How much is that? A by root 2. So diagonal is generally how to write diagonal square of the diagonal is nothing but how much? Root 2 into side we know. So diagonal value already we know that A by 2 equal to root 2 into side. Therefore side value you will get to know from here. How much is that? A by 2 root 2. Then remove shifted cutted mass if you want to calculate, no? M cut can be written as what? Sigma into A. A is nothing but what? Side square, na? A into A, na? A by 2 root 2 into A by 2 root 2. Therefore M cut equal to how much we will get it here? Sigma into A will be A square. 2 to the 4, 2 to the 4 and 2 to the 4. How much will get it? 8. So sigma A square by 8 we got it, M cut value. Now what we are going to calculate similar way. Similarly, we are going to calculate mass remaining. To calculate mass remaining, we need to calculate first total mass. So total mass how can you calculate? M total equal to sigma into A square, sigma into A, right? Sorry. Therefore M total equal to sigma into A value pi into R square. In the place of R, what we are having here? Radius R by 2 we are having. R by 2 whole square. Therefore M total equal to what we are having here? Sigma into pi R square by 4 we are having here. Pi R square by 4. This is either thing we have to take same thing. Otherwise we take this is our R. R square it will become, yeah, this should be R by 2. Yeah. Now if you observe, no, from these all things, which all things common, no, you have to remove, I told you. For example, what we are having, sigma is there, we can remove sigma, and R square is there, in denominator 4 is there. So MT equal to, MT directly proportional to pi if I write now here, M cut directly proportional to what we can write it here, sigma R square will go, by 4 also will go, so what remains here? 1 by 2, we can write it here. Now otherwise if I write M cut equal to 1 means MT can be written as what here? 2 pi. Twice of that. It is half, no? It is pi means twice of that, no? It is 1 means this is 2 pi, we can write it here. Now we just have to follow the formula. What we are having? M cut into, sorry, the total removed mass we need to calculate, na? M remaining equal to what we can write it? M total minus M cut, na? M total minus M cut. That's nothing but how much? 2 pi minus 1 we are having. Okay. Now let me write the m remaining into x remaining is equal to m cut into x cut. Therefore m remaining is how much? 2 pi minus 1 into x remaining we need to calculate equal to m cut value is how much? 1 we considered into x cut value how much we got it? R by 2. R by 2. Therefore x remaining equal to what we get it here? R by 2 into 2 pi minus 1 which we got it here. This is the shift in center of mass. But removed mass which side you have to observe here? Right side you remove, no? So it will shift will be left side, no? That's why we have to give a negative sign here. So listen once again. So for this square, if you want to calculate mass, you need to calculate side length. So diagonal value how much? R by 2. R by 2 means diagonal can be written as what? Root 2 into side na here. So R by 2 equal to what you can write here? Root 2 into side. Therefore side equal to R by 2 root 2 will get it here. So m cut can be written as what here? M is nothing but sigma into A na for sheet. So sigma into A is nothing but side into side. R by 2 root 2, R by 2 root 2 which we did here. So m cut equal to what we get it? Sigma R square by 8 which we got it here. M cut if you consider it as 1 and m cut if I am considering like 1 here. So m total I am calculating. From m total what I am doing? M remaining if you want to discuss, no, m total minus m cut. That's nothing but how much we will get it? 2 pi minus 1. So next we are going to use the same thing in our law which I am having, no. So we are going to substitute here. We got what we got it? Minus R by 2 pi minus 1 we are having. Otherwise, in the place of pi 3.14 we can substitute and we can calculate here. Next slide, let me look into next question here. See next slide what they are asking means. See next slide they are asking question like this. From a solid sphere, of radius capital R, a small solid sphere removed of diameter R, find shift in center of mass. In the question what they're telling means they're having one sphere here. From that sphere whose radius is how much? Sphere radius R. From that sphere they're removing another sphere whose diameter is R. Diameter is R means radius is how much? R by 2 will get it here. Now we need to calculate what? Now we need to calculate, we need to locate the center of mass or shift in the center of mass we need to locate here. So this portion remains here. Now m cut first we need to calculate. M cut is how much here? M cut equal to, we have to go with this thing. Density is nothing but what? Mass, volume density, mass by volume. Therefore mass can be written as rho into V. So rho into V means rho into V, 4 by 3 pi R cube. In the place of R what we are having here? R by 2 we are having. So 4 by 3 pi R cube means R cube by 8 will get it. 2 cube means. Okay. Next what we are having here? M total we are having here. M total if you want to calculate now what will get it? Rho into 4 by 3 pi R cube will get it here. So if I consider this pi R cube like rho into 4 by 3 pi R cube by 8 we are having here. Rho into 4 by 3 pi R cube we are having here. So what all the common things is there? That's why we are going to remain common things. M cut directly proportional to what we can write it here? 1 by 8. M total directly proportional to what we can write it? 1. So M remaining we need to calculate. Now M remaining can be written as what, Nana? M total minus M cut. That's nothing but 1 minus 1 by 8. 1 minus 1 by 8 can be written as what here? This 8 will go here. 8 minus 1 is nothing but 7 by 8. We got it. M remaining. Now let me apply law here. What is the law? M remaining into X remaining is equal to m cut into x cut. So m remaining, how much we are having? 7 by 8 into x remaining, shift we need to calculate. M cut value, how much we got it? M cut is nothing but 1 by 8 into x cut. X cut value is nothing but r by 2. So 8 will get cancelled. X remaining equal to what will get it? R by, this 7 will go to denominator na, 14 na. So this is the answer for this question. If you solve by regular method also will get it, but by using this law it will save a lot of time for you. And here which sign will get it means you should get negative sign here. Why? Because I'm cutted, it is right side, shift will be which side will be go? Right side, left side will be going na shift. That's why we need to take the answer as negative we need to take. So let me take one question here, one more question. In this question what they are asking means, let me change the slide. This is one NEET question, NEET standard question. A regular hexagon they given. Regular hexagon. So they given in regular hexagon like this. Each corner what they place means mass m they placed. Each side mass m they placed here. What question they are asking means, question they are asking like this. If one mass is doubled, then find shift in center of mass and second question they are asking like this. If one mass is removed, then find shift in center of mass. It's very clear for regular hexagon where the center of mass lies means exactly the center somewhere here locates generally. Now what they are telling means in first question they are going to add one mass here. They are going to add one mass here means, so let me write plus m, one more mass in this corner they added here. Okay, so added mass. So where does shift will come, we have to check here. So what is the formula we are having here? M remaining into x remaining is equal to m add into x add. M remaining is how much? Earlier total mass is how much? 1, 2, 3, 4, 5, 6. Now added is how much? Plus 1. So m remaining directly we can write 7m into x remaining is equal to m added is how much? M. From center of mass at what distance it is added? A distance of x, a distance of a, let me take side length. How much they give in the question? L they given. L they given. So a distance of L they added. So L we need to write. Therefore x remaining equal to what will happen here? Mm will get cancelled. L by 7 we got it here. Next for second question what they are doing here? Shift will come which direction? In this direction will come shift. Somewhere here new center of mass you can observe here. Now next question what we need to do? If one mass is removed, total mass will become how much? 6m minus m is nothing but 5m. Therefore m remaining into x remaining equal to m cut into x cut. So if one mass is removed, any one mass, let us assume one mass there, generally in 6 masses, this mass only they remove, let us assume this corner only. So what will get it? M remaining is how much? M remaining is nothing but 5 masses into x remaining. At what distance we remove from center of mass means again L equal to, we need to calculate x remaining equal to m cut is how much? M we removed. At x cut what distance? L. Mm will get cancelled. Therefore x remaining equal to what will get here? L by 5 will come here. In which direction it is removed? It's go shifting means this direction it will shift now. Where total mass, more mass is there now, this direction center of mass will be going to shift. In this slide we are going to discuss about motion of center of mass. Motion of center of mass. So we know that position of center of mass, we know that. What is that? RCOM. RCOM equal to what we know? M1 R1 plus M2 R2 plus M3 R3 and so on. M1 plus M2 plus M3 up to where Mn we can write it here. The same equation we are taking here, and what we are going to do means we are going to differentiate both sides with respect to the time. So if you differentiate, what will get it? Let me check here. And differentiating both side with time. So d by dt of RCOM is equal to M1 if I take common now dr1 by dt plus M2 if I take common now dr2 by dt divided by what we can write here? M1 plus M2. So rate of change of displacement is nothing but velocity. Therefore, what we can write here? Velocity of COM equal to M1 dr1 by dt leads to V1, dr2 by dt leads to V2 here. Therefore, V1 plus M2 V2 divided by M1 plus M2. So this is nothing but what? Velocity of center of mass, which we are going to discuss here. Velocity of center of mass, which we got it here. Next, what we are going to do? Again, we are repeating same thing and differentiating both sides with respect to time. And differentiating both sides with respect to time. What will get? Let me check here. D by dt of VCOM is equal to M1 into dV1 by dt plus M2 into dV2 by dt divided by M1 plus M2. So this will become what? V2. This will become what here? V1. Therefore, dV by dt, rate of change of velocity nothing but, this will become acceleration 1, this will become acceleration 2. Rate of change of velocity nothing but acceleration 2, that's why. So what we can write it? Acceleration of center of mass can be written as what here? M1 A1 plus M2 A2. So this is nothing but sigma m. Now if I shift sigma m LHS side now, so sigma m into ACOM is equal to M1 A1 plus M2 A2. Here divided by M1 plus M2 is there before switching. This is acceleration of COM. So this also can be written as what? MA is nothing but foresight. Sigma FCOM can be written as what here? M1 A1, F1 plus F2 plus F3 and so on we can write it. This is nothing but what we can discuss here. Motion of center of mass. Some numericals based on motion of center of mass. Let me take one example here. And that example says two particles is a mass m1 equal to 1 kg and mass m2 equal to 2 kg. m1 is moving with velocity v1 equal to 2i cap plus j cap minus k cap, and m2 is going with velocity v2 equal to I cap minus j cap plus k cap. Calculate velocity of center of mass they are telling. Velocity of center of mass formula what we are having, just now we have derived that VCOM equal to m1 v1 plus m2 v2 divided by m1 plus m2. So VCOM equal to m1 value is how much? 1, right? 1 into v1 value 2i cap plus j cap minus k cap plus m2 into 2 into I cap minus j cap plus k cap divided by m1 plus m2, 1 plus 2. Therefore VCOM equal to, if you open the brackets now, 2i cap plus j cap minus k cap. So we need to multiply with 2 in second case. 2i cap minus 2j cap plus 2k cap divided by total mass is nothing but 3. Therefore VCOM equal to what we get here? 2i cap plus 2i cap, 4i cap minus 2j cap minus plus k cap means minus j cap minus k cap plus 2k cap will be plus k cap divided by 3. This is the answer for this question which we got it here. So this is nothing but simply velocity of center of mass which we are having. So some cases they will ask you, so velocity of center of masses, these all things they can ask you now. So in next case to solve the numericals, first we know that F net equal to MA we know, we have to remember that one formula. And we know that V equal to U plus AT. For center of mass case, how can you write it here? Velocity of center of mass equal to U of initial velocity of center of mass plus ACOM of into T, we can write it here. These all formulas are required still, which we learned in Newton's laws of motion also. How they are asking here, they given one block diagram like this. Here one pulley is there, it seems. Here they placed one block here whose mass is 1 kg. That 1 kg block is connected with a frictionless pulley with help of inextensible string 2 kg here. Okay, and they mention here this is x coordinate, this is y coordinate, they mention here. If blocks are released from rest, find velocity of center of mass after 2 seconds. So generally velocity of center of mass, if you want to calculate in a year, you have to know what due to what it's going acceleration. Due to 20 newtons only it's going down, Nana. Due to 10 kg 10 newtons and normal force will get cancelled, it's very clear. Only force is there means 20 newtons. So what you can write here means F net equal to what we know here, MA, sigma MA in fact. F net equal to how much you are having is sigma MA, or acceleration equals to F net by sigma MA earlier given, you can remember that formula also, sigma M. Therefore A equal to what we are having, F net value is how much, 20 remains here, 20 divided by sigma M, 1 plus 2 is nothing but 3. So that's nothing but 20 by 3 meter per second square, we got it. This block is going down like this about the negative y axis, this block is going about the positive x axis. Direction is important here because we are going to discuss about the center of mass motion. So now if you want to calculate VCOM, we need to calculate acceleration of COM. Acceleration of COM can be written as what here, M1A1 plus M2A2 divided by M1 plus M2. Therefore ACOM equal to M1 into M1 is how much, 1 kg into A1 value is how much, A I cap I am writing because positive x axis, na, A I cap plus M2 value is how much, 2 into, this is about negative x axis, right? So A minus J cap I am writing here divided by M1 plus M2, 1 plus 2 is nothing but 3, 1 plus 2, okay. Therefore ACOM equal to what we got it here, ACOM equal to acceleration value is how much, 20 by 3. So 20 by 3 I cap minus J cap divided by 1 plus 2 is nothing but minus 2 J cap, na. This 2 is there, na, here, divided by 3. Therefore acceleration of COM we got it like 20 by 4 into 20 by 9, na, 3 is 9 into I cap minus 2 J cap we are having here. Now velocity of center of mass we need to calculate. Velocity of center of mass is nothing but UCOM plus acceleration of COM V equal to U plus AT, written, that's it. UCOM is how much, 0, this fellow going to become 0. Therefore VCOM equal to what will get it, acceleration of COM just now we got it 20 by 9 I cap minus 2 J cap into time after 2 seconds they are telling in the question 2. Therefore velocity of center of mass equal to what will get it here, 20 into 2 will be 40, 40 by 9 into I cap minus 2 J cap, which we can mention here. This is standard NCERT type question. For sure we have to understand. Very good conceptual question which we got it here. In this slide, let me check one more question in this based on center of mass. We are having one plane here. In this plane what we are having is two blocks we are having. This is 3 kg block and this is 5 kg block. Here we connected these blocks with what? We connected with a spring. On this block we are applying force F1 equal to how much we are applying means 20 newtons we are applying. On this block we are applying force F2 equal to how much, 12 newtons we are applying. Initially both were at rest, they told, means U1 value equal to 0, U2 value equal to also 0. Then first as a part A what they are asking means calculate acceleration of center of mass, and part B they are asking like velocity of center of mass after 2 seconds. After 2 seconds they are asking here. See, generally first what we need to calculate, acceleration we need to calculate, then we, by using v equal to u plus at formula, we need to calculate the velocity. So here UCOM value is 0, they given in the question. UCOM equal to how much? 0, because u1 is 0, u2 also 0. Fine. Now we need to calculate what? Acceleration of COM. Acceleration of COM can be written as what here generally? M1A1 plus M2A2 divided by M1 plus M2. So we know that force equal to what we know? F equal to MA we know. So in the place of M1 A1, what I am going to write? F1. So F1 plus F2 divided by M1 plus M2, which we can write it here. Therefore acceleration of COM can be written as what here? F1 value, how much we are having here? 20 I cap. It's about positive x axis. I am taking 20 I cap. 20 I cap minus 12 J cap. Sorry, I cap only. About negative x axis it is. So divided by M1 plus M2. 3 plus 5 is nothing but 8 will get it. 3 plus 5. So that's nothing but ACOM is nothing but 20 minus 12 is nothing but 8. 8 I cap divided by 8 we got it. 8 will get cancelled. Therefore 1 I cap meter per second square, which we got it, acceleration of center of mass. Now you need to calculate velocity of center of mass. What we know, velocity of center of mass equal to, you know that, UCOM plus ACOM into T. V equal to U plus AT. So UCOM value is nothing but 0. VCOM equal to what will get it? ACOM is how much? 1. After how much time? 2. Therefore what will get it here? Velocity of center of mass is nothing but 2 I cap meter per second, which we can comment. So this is nothing but answer for this question. Velocity of center of mass. This is nothing but answer for this question. And one more question I'm going to ask you here. You people have to solve as a homework. So what is the question means? Question says like this. We are having one pulley here. So with the help of the pulley, we connected one block here which is having mass m1. Another block which we connected here, mass m2. So if m2 is greater than m1, what will happen? This block will go down to this direction. This block will go this direction. Already acceleration we calculated in where? Newton's laws of motion, we learned that m2 minus m1 into g divided by m1 plus m2. In the question they are not asking acceleration. Acceleration of center of mass they are asking. This is also standard NCET question. So dear students, please practice this question as homework. And this is for today's lecture. So for PDF of this lecture, check in description box. Thank you.